All right, I'm going to do just a quick review of the conscious relay pathways and the divergent pathways out of the module. So this information is all in the module, and then we're going to go into the information for the divergent pathways. So conscious relay pathways, they bring information about the location and type of stimulus to the cerebral cortex. They're high fidelity with accurate details about stimulus and location. They're somatotopically arranged, so the information in the brain is arranged similarly to actual anatomic arrangement. Okay? The dorsal column, so the two tracks are the dorsal column medial lemniscus system, which transmits discriminative touch and conscious proprioception. Stereognosis, which is the integration of touch and proprioception to identify an object such as a key without using vision. So it's the digging in your backpack sense. The spinothalamic system, the fast pain system from the spine to the thalamus. The discriminative fast pain and temperature and coarse touch. The fast pain, which is the sharp initial pain, it's well localized, also known as spinothalamic pain. It identifies the site of injury. The information is carried in those A delta fibers. To be aware of sensation, information must travel to the thalamus for crude awareness and to the cerebral cortex for discrimination, for discriminative and fine resolution. So the somatosensory cortex is where that information goes. So this is our little, the path of the conscious relay pathways from the peripheral receptor to the medulla, from the medulla to the thalamus, from the thalamus to the cerebral cortex. The information crosses over from the opposite side of the body, from the side of the body to the opposite side of the thalamus. So that's going to come into effect if we have a spinal cord injury or a brain injury where the deficit shows up. Okay, and then that is our graphic from the book. First order neuron, that from the body and from the face are a little bit different, but it shows the pathway. Okay. The dorsal column medial lemniscus pathway conveys information about fine touch and proprioception, crosses over to the contralateral side of the body in the medulla. So if you have a spinal cord injury that's below the medulla, which that your whole spinal cord is below the medulla, you're going to get different information. If you have an incomplete injury, you're going to get different information from different sides of the body. There's a video. Your option to watch it or not. The spinothalamic tract is the fast pain, temperature, and crude touch sensations. It crosses over to the contralateral side of the body in the dorsal horn of the spinal cord. So it crosses over lower than the dorsal column medial lemniscus, meaning you're going to have different changes in sensation depending on the level of the lesion with a spinal cord injury. There's a little song to remember the dorsal column medial lemniscus and spinothalamic tract if you like that kind of thing. There is a pretty long video, 15 minutes long, comparing tracks. About 11 minutes in, he talks about ways to remember a bunch of divergent information, which I think is helpful, but it's more detailed than we need for this class, so if you don't want that extra information, please don't spend 15 minutes watching the video. It's a waste of your time. If you want extra information, go nuts. Okay, so the divergent pathways, also known as the medial pain system, they transmit information to various areas of the brainstem and cerebrum. The reason I'm repeating this information from the previous section of the lecture is because you have to repeat to remember. We have to stimulate your brain. The divergent pathways carry the affective dimension of pain, meaning the emotional dimension of pain. It's a big part of pain. The information is not somatotopically organized, so it's not well localized. The divergent pathways carry conscious and unconscious information, and that goes from the free nerve endings in the C fibers to the dorsal root ganglion, to the spinal cord, to the medial pain system, and we'll talk about the three tracks, to various areas. So that's the divergent part. Slow pain travels in the anterolateral columns. This is the other pain. Fast discriminative pain travels in the dorsal columns. Those are the A delta fibers. So the three different tracks in the divergent relay pathways are the spino-mesencephalic, spine to midbrain. It functions to turn the head and eyes towards the source of pain and activates descending tracts that control pain. To be continued in Chapter 7. The spino-reticular pathway, the spino-reticular tract, involves arousal, attention, and sleep-wake cycles modulated by the reticular formation that goes from the spine to the reticular formation, just like the name tells you. It's severe pain waking you up from sleep. Ask any knee replacement patient, they'll tell you. Spinolimbic pathway is slow pain information, goes through the thalamus, so it's conscious. Remember, anything going through the thalamus is we're consciously aware of. And then it projects to areas involving emotion, sensory integration, and personality. Big, important things in the perception of pain. So we have the example of how it works that we talked about in the last section. These are some of the tracts. They talk about spinal reticular, mesencephalic, and spinal limbic, and the spinothalamic tract side by side comparing. The divergent systems cross over in the same level of the spinal cord. The spinothalamic system also crosses over in the same level or a couple levels up. The dorsal column medial lemniscus system crosses over in the medulla, in the midbrain. Okay, so sharp localized pain travels in a 3-neuron pathway. Slow pain travels in divergent pathways. So remember, for crude awareness, sensation must travel to the thalamus. This is written in bold with asterisk around it. You should probably know that. Okay, so the unconscious relay tracts are the last set that we're going to talk about. The unconscious relay tracts, they convey unconscious proprioceptive and other movement-related information directly to the cerebellum, which provides automatic adjustments to posture and movement. So there's only one set of tracts, yay, and it's the spinocerebellar tracts from the spine to the cerebellum. So like some of the other ones, the name gives you where it goes from and to. So it's afferent from the spine to the cerebellum. There are two tracts that have high fidelity information from muscle spindles, Golgi tendon organs, and cutaneous mechanoreceptors that go directly to the cerebellum. Two tracts are internal feedback tracts, including spinal reflexes and monitoring activity of descending motor signals. So the cerebellum, its job is to compare intended motor output with actual movement output and make little corrections to neural commands via other connections with other brain areas. So the cerebellum is constantly requiring this input of sensory information to modulate our posture and movement. So it's unconscious, it goes right to the cerebellum. The unconscious proprioceptive information travels in high fidelity pathways from the body to the cerebellum via the spinocerebellar tracts. Isn't it nice how the tracts tell you where they go and in which direction? We will find this to be true with descending motor pathways as well. There's a video, watch it at your discretion. Okay, so unconscious relay pathways, unconscious proprioceptive and other movement-related information carried to the cerebellum. Remember how in the conscious relay pathways we had conscious proprioceptive information? That's the stuff we're aware of. That's the stuff we can test with our when we're doing our sensory testing in the lab and in the clinic. The information in the unconscious relay pathways plays an essential role in automatic adjustments of movement and posture. So the unconscious relay tracts transmit information from proprioceptors and information about activity in spinal interneurons. They relay that information, which is critical for the cerebellum to adjust our movements. Inadequate proprioceptive input can cause ataxia, which is incoordination, because of the loss of sensory feedback, which disrupts movement control. So, inadequate proprioceptive input from the periphery is called sensory ataxia. There's also central ataxia, and there are ways to test, and we'll talk about it a little bit later, There are ways to test the difference, like whether it's sensory, it's a peripheral problem, or it's a central problem. And but if someone has peripheral neuropathy due to diabetes or other issues, they're going to get inadequate proprioceptive input, and that's going to disrupt their movement control and balance. So ataxia, discoordination, you should know the definition of that, and it can be peripheral or it can be central. When it has to do with inadequate proprioceptive input from the periphery, it is peripheral ataxia or sensory ataxia. So we have there are two pathways in the unconscious relay tracts, the posterior and the cuneo-cerebellar pathway. I do not expect you to know that. I just want you to know that they're both spinocerebellar pathways. But one transmits information from the legs and lower half of the body, and the other from the arms and upper half of the body. Kind of interesting, but there you go. The internal feedback tracts are the things, they're tracking the activity of spinal interneurons and descending motor signals, so it allows the cerebellum to compare intended motor output with actual motor output and then make adjustments as needed. The information in the spinocerebellar tracts comes from proprioceptors, spinal interneurons, and descending motor pathways. The information does not reach conscious awareness, but it contributes to automatic movement adjustments and postural adjustments. So this stuff is all going on below our level of consciousness. Okay. So there are a bunch of videos in the module. If you want a different explanation, you want a different way, I've specified how many minutes are in each one so you can decide if you want to spend that time. These are optional. You do not have to watch them. But sometimes seeing it explained in a different way is helpful for understanding the different pathways. So in the next section, we're going to start talking about somatosensory testing and somatosensory exams, and really start talking about the information in Chapter 7.